Hey, what's going on, guys? Let's do this problem right here. The question is asking determine whether the following series converge or diverge. And we have this one right here. And we are going to do the limits comparison test. But to do that, first thing we have to do is we have to take the dominant terms of this function. And if you look at this one, in the numerator we have square root of n, and in the denominator we have n, right? And we have to find whether this one converge or diverge, right? So if we find this one converge or diverge, and then when we do the limit comparison test, and if we get a positive finite number, that means it also behave as this one. So let's see whether this one converges or diverges, right? So let's see how we can find this one out. First of all, this is n power half. So this is same as, so you can write this one as square root of n and this one as square root of n multiplied by square root of n, right? Same thing. Square root of n multiplied by square root of n, that's going to give you n. And from this one we can cancel these two, and that's going to give us 1 over root n. 1 over root n is same as 1 over n power half, right? And also if you notice already, this is a p series. How to identify a p series? If you have a n power and a number, that's a p series. If you have a power and n, that is geometric series. So this is a p series right here. And in a p series, if the power is greater than 1, it's divergent. If it's less than 1, or if it's greater than 1, it converges. If it's less than 1 or equal to 1, it diverges. Here this one is less than 1 or equal to 1. Here it's less than 1, right? It's power half, so it's less than 1, so this one definitely diverges. So now what are we going to do? We are going to do the limits comparison test, and if we get the limit as positive finite number, that also diverges. Let's see whether we get a positive finite number, right? So let's go ahead and take the limit. So in order to take the limit, what we're going to do, limit approach n approaches infinity, and this is going to remain in the top. The main function remains in the top. 2 square root of n plus 3 over n plus 5, and then we divide by this one by this value, 1 over n power half. But dividing by 1 over n power half is same as multiplying by n power half over 1. It's going to flip around, right? When you divide, it's going to flip around, so it is same as this one. So we can keep it this way, and let's multiply. And here we have 2 square root of n power half, so let's write this one in square root. So this is going to be limit n approaches infinity, 2 square root of n power 3, n plus 3 over n plus 5, and this is same as square root of n over 1. Let's see how we can simplify this one. So what we can do is we can just simply multiply this square root of n with both of them. So that's going to give us limit n approaches infinity, 2 square root of n square plus 3n. I just multiply this n with this 2. So that's going to give us this value, and in the denominator we are going to have n plus 5, right? So this is what we have. Now what we can do is, to find the limit, what we do, we divide everything by the highest power. And if you notice, the highest power here is n, but within the square root is n square. But if you take this one out of the square root, that's going to be n. But when we put this one in the square root, we are going to put n square, and out we are going to just put n, right? So let's take the limit. So limit n goes to infinity, 2 square root of n square. I'm dividing by n square. This is same as n dividing by n, because since this is inside the square root, that's why we put square. So this is also going to be divided by 3n over n square, and outside is going to divide by n plus 5 over n, right? So that's how we do the limit. And let's simplify this one. So here we are going to have limit n approaches infinity, and then we are going to have 2 square root of 1 plus 3 over n and then in the denominator we have 1 plus 5 over n, right? And everything that has n in the denominator is going to be 0. So we know that this is going to be 0. This is also going to be 0. Therefore, if you take the limit, that's going to give us, so let's say this is equal to 2 over 1, because square root of 1 is still going to be 1. 1 multiplied by 2 is still 1. 2 over 1, that's going to be 2. So the limits is a positive finite number. So this means this main function behaves as this function. We know this is diverges, therefore this also diverges. This also diverges. And that's how we do the limits comparison test. I hope you guys find this video helpful. See you next time.